Schließlich haben wir es zu tun mit den Gewinnern der Vorrunde aus Oberpfaffenhofen und das sind diese Herrschaften hier.
This thing called love, I just can't handle it. This thing called love, I must get around to it. I ain't ready. Crazy little thing called love.
Sogno Daniele Cerra, sogno italiano. Dal 2007 passo tempo al centro di telerilevamento e analisi di immagini dello DLR, Turuzzo Caponnina.
It jives. Shapes all like a jellyfish. I kinda like it. Crazy little thing called love.
Ich heiße Claas Grohnfeldt und schreibe seit 2 Jahren meine Doktorarbeit am Institut für Methodik der Fernerkundung in Oberpfaffenhofen in der Abteilung Saar-Signalverarbeitung.
There goes my baby. She knows how to rock and roll. She drives me crazy. She gives me hot and cold fever. She leaves me in a cool, cool sweat.
Hola, soc la Maria Tello, soc espanyola. Estic treballant al DLR, a l'Institut d'Alta Freqüència i Radar, des de fa 5 mesos i estic molt feliç d'estar fent aquí un postdoc.
Take a backseat, hitchhike. I take on a ride on my motorbike until ready. Crazy little thing called love.
Sono Michele Martone, sono italiano e lavoro al DLR all'Istituto di Radar e Microonde da circa 4 anni.
Kevin Alonso naiz, Espainiatik nator, Euskal Herritik, eta orain dela 6 hilabete nire doktoratua erekin hasi nintzen, Remote Sensing Institutoa.
I gotta be cool, relax, get hip, get on my tracks, take a backseat, hitchhike, and take a long ride on my motorbike until ready. Crazy little thing called love.
Меня зовут Aliaksei Makarau. Я працюю в немецком аэрокосмическом центре наприкінці 2009 года.
This thing called love, I just can't handle it. This thing called love, I must get around to it. I ain't ready. Crazy big thing, DLR. Crazy big thing, DLR, mama. Crazy big thing, DLR, yeah, yeah. Crazy big thing, DLR. Crazy big thing, DLR.
Wir kommen aus 2 Instituten und aus 4 Staaten.
Wir verstehen uns nicht immer,
aber wir arbeiten dran. Versprochen.
Die glorreichen 6 aus Bayern, meine Damen und Herren. Tello Alonso, Michele Martone, Daniele Cerra, Aliaksei Makarau, Claas Hendrik Grohnfeldt und Kevin Gonzalez. Pep Guardiola kommt leider nicht, er sucht einen Maulwurf. Aber die anderen sind da, das ist doch schön. Herzlich willkommen. So, ja. So. Wir haben alle einigermaßen richtig gezählt. Es sind nur 2 von 6, aber wir lassen uns überraschen, ob das funktioniert. Sie beide sind soweit, gell? Wunderbar. Dann 10 Minuten Zeit, ab jetzt.
So let's start traveling back in time and paying a visit to Galileo. Galileo was one of the first observational astronomers to do remote sensing, which means employing an instrument to observe objects at long distances. By then, probably he was not even imagining that someday we would be able to reverse the point of view of the observation and to use satellites to observe the Earth from space. But Galileo was also an excellent musician, and music played a major role in most of his discoveries. So, following this inspiration, what would happen if we try to describe how remote sensing works in terms of music? What would happen if our instruments measure tones instead of electromagnetic waves? For example, The human eye can only see mixtures of 3 colors, red, green, and blue, which correspond to 3 different wavelengths. So, for example, we can represent a red pitch, which has a low frequency as a low tone. A green one, which has a shorter wavelength, would result in a higher tone. And the blue one would sound like this. And we can even combine these 3 colors in a white chord or in a gray one just by playing them more softly.
Okay, thank you very much. That's enough. I think the human eye will never be a successful musician. Not like me, at least.
Sorry, but who are you?
I am Mr. Hyperspectral. I am the one which is able to turn an image from this into this.
Great. And how can you do that?
But that's simple. I measure the reflected solar radiation at hundreds of different frequencies. And I can see in the ultraviolet and in the infrared, which are just invisible to you. Let me show you. With your digital camera, these mountains in Nevada look quite boring. But if now I sense with my hyperspectral sensor, for me, they will appear much different. And now I can tell you which rocks are there, and even their chemical composition, even the strangest ones. But modestly speaking, I'm so interesting that DLR is going to put in space a new hyperspectral satellite called NMAP in order to derive these products at a global scale.
That's awesome. And do all the sensors work like you?
But of course not. Imagine there are sensors that look at the world only in black and white. They are called panchromatic, and that's how a panchromatic sensor would see our mountains. You get a lot of information, don't you? They are so sweet.
Hey, I sing only with one note, but I have lots of things to say. You think you are so smart and cool, and all other sensors like me are just fools. It is true, I cannot change my pitch, but it's not a reason to treat me like an idiot.
My dear panchromatic sensor, what can I do for you?
I can see as selling you're so good, but you're not telling the whole truth. Let's go to Munich.
Please, let's go, yeah? Let's go.
Yeah, you notice anything strange here?
Nothing.
All right, now zoom in.
Yeah?
Aha! My Deutsches Museum is much sharper than yours.
Okay, but...
And if now I move a little bit in my panchromatic image from pixel to pixel, I can sing to you the different information I can find there.
Yeah, please have fun.
Because I am a panchromatic sensor. My friends say I'm boring, but they're just jealous. I can whisper and I can yell. And in my job, I'm doing pretty well.
Great job. Yeah.
Would you like to try?
Yeah, of course.
Come on, be my guest.
Yeah.
Sing to me what you can find in your upper spectral image at the same spot.
Of course I will do. I'm the hyperspectral sensor and I'm the hyperspectral sensor and I'm the hyperspectral sensor and why do I sing always the same?
Because you're still in the same pixel, you see? In the space you need to measure a big pixel like this, I can distinguish hundreds of them. And because it's true, I take only one measurement, but I do it on the full reflected solar radiation, while you divide the light in smaller, weaker components, and you measure them separately. So it's like we're seeing the same room, but I'm doing it under a much stronger light. Details are sharper, of course.
Okay, but...
Who dares talking about the light? Mine alone is the power of light, the power of the active sensor.
I'm sorry, sir. Who are you, and what is an active sensor?
Oh, I'm Lord Lighter, my pleasure. Let me explain.
Lighter?
Well, Mr. Panchromatic and Mr. Hyperspectral over there are passive sensors, which means that they only detect the solar radiation reflected from the Earth. I am my own energy source. I can send my own light pulses to the ground. And measuring the time my pulses take to travel to the ground and come back to me gives me the exact location of the objects I am pointing to. Yeah, let me demonstrate you my power, guys. And answer me. Ah, that was quick, so I sense Mr. Panchromatic is close. Ah, I sense Mr. Hyperspectral is far away. Now let's see what's on this side. Buddy, I'm a boy making big noise, sending out my light, gonna measure the world someday. You were quick, then you are close, you're slow, then you are far. No matter where you go, I will light you up. I will light you. I will light you.
Woo, tough guy.
Tough guy, huh?
I'm very small.
Yeah.
If I now fly over the city, I can use the acquired distance information to derive a three-dimensional model. And as an active, hard-working German, I'm doing this, of course, precisely, day as well as by night. Not like you passive Italian hyperspectral and panchromatic sensors that are always sleeping.
Who sleeps at night? Hey. Not me, for sure. Where does that? Where does voice come from?
Who dares interrupting Lord Leiter?
You cannot see me, but I can see you, because I not only work at night, but also see through the clouds. That's the power of SAR. SAR?
Synthetic aperture radar?
Yes, radar. I behave like a bat. I send pulses into a wide area and collect responses from several targets. To do this, I use microwaves with very low frequencies, like this.
Wow. This is powerful.
Indeed. Look, this was the sky over Göttingen this morning. Yeah, as usual. As usual, right?
That looks familiar.
Yeah.
Looks familiar.
But with my powerful microwaves, I can penetrate the cloud and get this nice image of Loch Halle.
Nice, nice, nice.
Hey, man,
Oh,
are you spying
nice.
on us?
Of course, and there is more. If you give me a companion, I can provide you with 3D information like Lord Lidar here.
Like me?
Yes, like you. And that's exactly what's being done by DLR satellites, TerraSAR-X and Tandem-X at global scale. So, guys, what do you think? Who is the best now?
That's
you
like
know,
me,
of
man.
course.
Come on.
Yeah. And you know,
Cyber
not
spectrum
even,
man,
come
take
on,
over
dress
there.
like you.
Man.
Come on. Hey.
Isabel, Caesar.
Who is this guy now?
Man, he looks like a chemist, doesn't he?
No, I'm not. I'm Dr. Fusion.
Doctor?
Fusion?
Yes, I am.
What's this fusion thing?
Let me show you. So fusion means that each of you has unique characteristics and yes, you can work together.
Work together? No, I am
Yes, we can.
Can't believe it.
It will never work.
Definitely not.
Let me show you, Mr. Panchromatic.
Yeah?
Let's go back to Munich.
No.
What should I do in Munich?
Look through.
Let's see what I can find there, yeah.
With your information, it is so sharp, so precise. We can look at the objects, we can get the geometry of the objects and the scene. And Lord Lidar, please come back to us. Lord Lidar, talk to me, tell me. And with this elevation, we can get objects like houses, trees, cars, and so on. And you, Mr. Happy Spectral, play to us. And with this Happy Spectral information, we can get the materials, and I can tell you what all these roofs are made of. And you, Batman, SAR, go through, tell us. Yes, and among all this noise and speckles, we can find specific objects like cars and parking lots. And so, DR sensors, using all of you together, we can get a complete view of the scene. So, DR sensors, thank you very much. Thank you.
So, ladies and gentlemen, this is DLR, scientists from different backgrounds looking at the world from different but complementary perspectives. As we try to represent today, we believe that these different perspectives can play very nicely together sometimes. And we also believe that this is a unique strength here at DLR, and that collaborations are to be boosted, since interactions spark creativity and can result in great achievements. Because after all, diversity could be one of our greatest resources. Thank you.
We are the sensors. We are the sensors. No time for losers, 'cause we are the sensors.
Above the wall.